So hello friends, now we are solving set A of first internal test paper of computer oriented numerical method. So let's begin. Hello friends, now we are solving set A of first internal test paper and first question is find the cube root of 12 using Newton-Raphson method correct up to 4 decimal places. So this is the solution. We have equation x equals to cube root of n, and first we have to convert this equation into form of function. So function is f of x equals to x cube minus 12. Now we have to find the root for this function. So we can find root by putting different values of x. For example, 0, 1, 2, 3, etc. So first we will put x equals to 0 in this function and we get f of 0 equals to minus 12. Then we will put x equals to 1 in function and we get f of 1 equals to minus 11. Similarly, on putting x equals to 2, we get f of 2 equals to minus 4. And on putting x equals to 3, we get f of 3 equals to 15. We will stop when we get one negative value and one positive value for the function. So we will consider that our root lies between 2 and 3. Now we will choose initial value for x0 which is 2.5. We have chosen 2.5 because on putting 2.5 in a function we get f of 2.5 equals to 3.625, which is nearest to 0 or closest to 0. Now we have a general formula for finding cube root, which is xn plus 1 equals to 1 by 3 under bracket 2xn plus n divided by xn whole square. Now we will put n equals to 12 in this general formula because we have to find cube root of 12. So when we put n equals to 12, we get xn plus 1 equals to 1 by 3 under bracket 2xn plus 12 divided by xn whole square. Now for first iteration, we will put n equals to 0 in this formula and we will get x1 equals to 1 by 3 under bracket 2x0 plus 12 divided by x0 whole square. On putting the value of x0 in this formula, we get x1 equals to 1 by 3 2 into 2.5 plus 12 divided by 2.5 whole square. On solving, we get x1 equals to 2.3066. Now, when we put n equals to 1 for second iteration, we get x2 equals to 1 by 3, 2x1 plus 12 divided by x1 whole square. On putting the values of x1, we get 6.868 divided by 3. On solving this, we get a value of x2 equals to 2.2894. Now, this is the approximate cube root of 12, 2.2894. Now, our next question is write an algorithm or flowchart for finding square root of 12 using fixed point iteration method. So this is the solution. We have algorithm for finding cube root of 12 using iterative method. So first step is start. Then say in second step we will define a function f of x. Then in third step we will define function g of x which is obtained from f of x equals to 0 such that x equals to g of x and g dash x is less than 1. Then in fourth step we will choose initial guess x0 and error e and maximum iteration n from the user. Then in fifth step we will initialize iteration counter step equals to step plus 1. Then in sixth step we will calculate x1 equals to g of x0. Then in seventh step we will increment iteration counter step equals to step plus 1. Then in eighth step we will check a condition that step is greater than n. If it is true, we will print it is not convergent and move to step number 12. And if it is false, then we will move to step number 10. Then in step number 9, we will set x0 equals to x1 for the next iteration. Now in 10th step, we will check a condition f of x is greater than e. If it is true, then we will move to step number 6. And if it is false, then we will move to step number 11. Now step 11 is display x1 as a root. Then in 12th and the last step is stop. Now we will move to our next question. And our next question is give the stepwise output of Gauss-Jordan algorithm for given matrix. We have given a matrix and we have to find this matrix solution by the help of Gauss-Jordan method. So we have four rows R1, R2, R3, R4 and five columns, column 1, column 2, column 3, column 4, column 5. We will perform various operations, row operations to find uh, Gauss-Jordan method. So first we have to convert our matrix in this form by the help of diagonal elements. We have to convert our matrix in form of identity matrix. So our original matrix is this. First, we have to convert these elements as 0 by the help of diagonal element, which is 10. So we will perform operation on R2, R3 and R4. So R2 tends to R2 minus under bracket 6 by 10 R1. And for R3, R3 tends to R3 minus 3 by 10 R1. For R4, R4 tends to R4 minus 5 by 10 R1. On solving this operation, we will get a new matrix, which is this. Now we have to convert 3.1 and minus 5.5 and minus 7 as 0 by the help of this diagonal element 3.8. So we will perform row operation on R1, R3 and R4, which are R1 minus under bracket 7 by 3.8 R2. Then for R3, R3 minus 3.1 divided by 3.8 R2. For R4, R4 minus under bracket minus 5.5 divided by 3.8 into R2. On solving this operation, we get our new matrix this. Now we have to convert minus 2.34, 0.8 and 4.47 as 0 by the help of this diagonal element 2.44. So we will perform row operation on R1, R2 and R4. So these are the row operation R1 minus under bracket 4.47 divided by 2.44 R3. And for R2, R2 minus 0.8 divided by 2.44 into R3. And for R4, R4 minus under bracket minus 2.34 divided by 2.44 R3. On solving this operation, we get a new matrix, which is this. Now we have diagonal element 9.93 and we have to convert upper elements as 0 by the help of this diagonal element. So we will perform row operation on R1, R2 and R3. On performing row operation, we have for R1 minus under bracket minus 15.73 divided by 9.93 R4. For R2 tends to R2 minus under bracket minus 4.38 divided by 9.93 R4. For R3, we have R3 minus under bracket 10.31 divided by 9.93 into R4. And we get a new matrix, which is our final matrix. Now we have to find the values of W, X, Y, Z. So for W, we have 10W equals to 49.99, 3.8 X equals to 15.19, and 2.44 Y equals to minus 17.08, and 9.93 Z equals to 9.90. On solving, we get W equals to 49.99 divided by 10, X equals to 15.19 divided by 3.8, and Y equals to minus 17.08 divided by 2.44, and Z equals to 9.90 divided by 9.93. So thank you friends. I hope you like this video. So please like, share and subscribe, and never forget to press the bell icon for latest videos. So thank you.